Good morning, and now we'll have another topic in our subject statistics and probability, which is the normal distribution. The competencies that we will try to master with this topic are we have illustrates a normal random variable and its characteristics with the code M11 or 12 SP-IIIC-1. Next is the identifies the regions under the normal curve corresponding to different standard normal values. Third, converts a normal random variable to a standard normal variable and vice versa. And lastly, computes probabilities and percentiles using the standard normal table. Let's have the objectives of today's lesson. First, describe a normal random variable and its characteristics. Second, determine the area under the regions corresponding to different standard normal values. Third, convert a normal random variable to a standard normal variable and vice versa. Fourth, calculate probabilities and percentiles using the standard normal table. And lastly, solve problems involving normal distribution. Are you ready? Let's start with the activity number 1. The activity number 1 with the title Let's Graph. So we have here a situation wherein you have the table of scores of selected grade 11 Garnet of Cabaco National High School who took the first summative test in statistics and probability last week. So here are the data. So we have here 1 got 15, 3 got 12, 5 got 9, and 3 got 6, and 1 got 3. So a total takers of 13. So what you need to do is to construct a bar graph based from the table. So I'll give you 2 minutes for that. And now let's try to construct our bar graph. So for our horizontal part, we have the scores 3, 6, 9, 12, and 15. And for the vertical, we have the frequency, the 0, 1, 2, 3, 4, 5, and 6. So let's start graphing our data. So we have only one taker who got 3 points. 3 takers got 6 points. And then 5 takers got 9 points. And 3 takers got 12 points. And there's only one taker got 15 points. So we have here a question. What does the graph look like? Later on, you will know the answer. Let's move on to the next slide. Activity number 2 with the title Let's Solve. So we have here a formula given that z is equal to x minus mu over sigma. Let's solve for the value of z. We have here an example. X is 25, mean or the mu is 22.5, and the standard deviation or the sigma is 2. Using the formula z is equal to x minus the mean all over the standard deviation, we substitute the given 25 minus 22.5 divided by 2. Let's start with the numerator. When you say 25 minus 22.5, it's 2.5. Again, divided by 2. So we have here 2.5 over 2, that is 1.25. So for x that is 25, our z is 1.25. Let's start. What will be the value of x equals 98, the mean is 110, and the standard deviation is 5. Use the formula. Now, we have this. Based on the formula, we substitute it. Z is equal to 98 minus 110 all over 5. So what is 98 minus 110? That is negative 12 over Then copy the denominator, which is 5. Simplify negative 12 over 5 is negative 2.4. So for x that is 98, our z is negative 2.4. Next, a score of 13, a mean of 11.4, and our standard deviation with the symbol of sigma, which is 1.5. Use the formula. So, by substituting the values, we have here z is equal to 13 minus 11.4 all over 1.5. We subtract 13 to 11.4, we got 1.6 and copy the denominator, which is 1.5. And simplifying 1.6 over 1.5 using our calculator, we got an answer which is 1.17. So our z for number 2 is 1.17. Let's have number 3. Our x is 15, our mean or mu is 13, and our sigma is 3. Again, we'll use the formula. Substituting the values to the formula, we have here z is equal to 15 minus 13 all over 3. Then the difference between 15 and 13 is 2. Then copy the denominator 3. So it's 2 over 3. Or by using the calculator, we got 0.67. So our z is 0.67. And for the last item, we have here score 34, mu, which is 35, and our SD is 2.5. Again, use the given formula. By substituting the given to the formula, we have here 34 minus 35 all over 2.5 is equal to z. And then we have here negative 1 divided by 2.5. And we come up with an answer of negative 0.4. Okay, so we're done with activity number 2. So now we are here, firm up your understanding. Let's start with the normal distribution. When we say normal distribution, it is the most important and most widely used distribution in statistics. It is sometimes called the bell curve, or also called as the Gaussian curve from the mathematician Carl Friedrich Gauss. Normal curve. When we say normal curve, it is a bell-shaped curve and it represents a normal distribution. Remember, in our activity number 1, we are asked on what does the graph look like? And it looks like a bell. So an example of normal curve. This is an example of a normal curve. So it looks like a bell. So that's why it's called a bell-shaped curve. Now we have here the standard normal curve. So standard normal curve is a normal curve with a mean, which is represented by mu is equal to 0, and standard deviation with a symbol of sigma is equal to 1. And this is the example of our standard normal curve. Let's continue with the characteristics of a normal curve. A normal curve has values of mean, median, and mode which are the same. So the mean, the median, and mode, they have the same value. And it is a unimodal distribution because there's only one peak of the curve. So, and there's only one mode. And based on our illustration a while ago of the normal curve, it shows symmetric distribution. So as 50% of the data set lies on the left of the mean, and the other 50% lies on the right side of the mean. Some examples for normal distribution. We have first here the height and weight of the subject's understanding. So most of the studies involving height and weight, um, the data is normally distributed. And also the IQ scores of the students. So if you have study involving IQ scores of the students, so the data that you will be collected is normally distributed. Now we are here in part wherein we have to convert the normal scores to standard normal scores or standard scores. Or sometimes we call them as z-scores. So the formula, so this formula is the formula that we use in our second activity wherein z is equal to x minus mu all over sigma, where x is the normal score and mu is the mean and the sigma is the standard deviation. So let's try to solve or try to convert a normal score to z-scores. So sample, we have here. The grades on General Mathematics of Cabancola National High School are normally distributed with a mean of 76 and a standard deviation of 2.5. Anthony has a grade of 73. Find the z-score for Anthony's grade. So, based on the given situation, our x here, our normal score is 73. And our mu or the mean is 76. And our sigma or the standard deviation based on the given is 2.5. So we already have our needed values. So we will substitute them to our formula. Our formula again is z is equal to x minus mu over the standard deviation. So by substituting the values based on the given, 73 minus 76 all over 2.5. And we have here negative 3 over 2.5, which is equal to negative 1.2. So therefore, the z-score for Anthony's grade is negative 1.2. Now we'll have our z-score table or the standard score table. So we'll use this table in our next activities. So introducing the z-score table. So we have here, inside the table are the different probabilities or areas under region. So later on, we will know the use of this z-score table. So we are now on the topic about computing the area under the region of corresponding standard scores. So use the z-score table to determine the area under the region of corresponding standard scores. So the given or the previously given table, we will use it for our activity here or for our task, which is to compute for the area. So there are following conditions in using the z-score. So first, if z is less than positive value, the area is just the value given on the z-score table. But if the z is less than negative value, the area is 1 minus the value on the z-score table. Next is if the z is greater than positive value, then the area is 1 minus the value on the z-score table. And if z is greater than negative value, then the area is the value on the z-score table. Later on, we'll discover on why do these conditions exist. And then if z is between two numbers, example, z is greater than a but less than b, then the area of z less than b minus the area of z less than a. So that's how to compute for the area. So please take note of the 5 conditions in solving for the area under the region of the different or corresponding standard scores. So now, examples in computing for area under a region. Let's start with the first condition. So the first condition is about if z is less than a positive value. So let's try to find the area under if z is less than 2.15. So remember, this is our standard curve or standard normal curve. So we'll try to locate 2.15. So 2.15 is somewhere there in the border of the line, color blue line. So 2.15 is there. So when we say less than, if z is less than 2.15, meaning to the left of that line. So we'll shade all the under the curve of the left and the left of that line, color blue line. So that will be the area that we are looking for. Looking at it, it's more than half of the curve. Half of the curve is 50%, which is 0.5, because the whole curve has an area of 1. So half of it is 0.5, but it's more than 0.5 based on the illustration. So in order for us to exactly determine the exact value of the area under z less than 2.15, we'll use the z table. But how to use the z table? So this is our z table a while ago. So I'll just cut it under in that form. So how to use the z table? First, we locate the first two digits of 2.15. The first two digits of 2.15 is 2.1. So you locate them in the first column. Where's the first column? That is the first column. So we will locate the 2.1 there. So where's the 2.1? That's the 2.1. The next step is to locate the last digit. The last digit of 2.15 is the 0.05. So it is found in the first row. So we have there the first row. So we will locate 0.05. After that, locate the intersection. So the intersection is 0.9842. Since this is an example of the first condition, meaning the term that is on the intersection is the value of the area. And therefore, the area is 0.9842. And we are correct because it is greater than 0.5. Based on the illustration, it is more than 0.5. And based on the table, the answer, the area for our region under Z is less than 2.15 is 0.9842. Next, example for the second condition. So for the second condition, we're looking for area under z is less than a negative value, and we have here z is less than negative 1.54. Again, we have here the standard curve. So we'll try to locate the negative 1.54. So we have there the blue line, that's the um, precisely the position of negative 1.54. And since it's less than, so we'll try to shade the left of that line. So that one. So looking at it, the area is just less than 0.5, right? Because it's less than half of the curve. So now we have here our z table or the z-score table. What's the first step? First, locate the first two digits of 1.54 on the first column. So the first two digits of 1.54 is 1.5. So there, we have there the 1.5. Next is locate the last digit, which is 0.04 in the first row. Okay, we have already the 0.04 and then the intersection. So based on our second condition, the intersection here is the answer for the intersection is we are going to subtract it to 1. And the answer in our table, based on the table of the intersection, is 0.9382. So we subtract 1. So we have a 1 minus 0.9382, which is equal to 0.0618. Therefore, the area under z less than negative 1.54 is 0.0618. And based on our illustration, it is less than zero point 0.9. And yeah, we're confident that it is the exact value. Now let's have our third example in computing for area. This is the under third condition. For the third condition, if z is greater than positive value. So find the area under z greater than 0.69. So if z is greater than 0.69, so let's try to locate 0.69. Yes, that's 0.69. Since it's greater than it's, we will shade the right side of that line. So that's the right side. So that's the area that we're looking for. And based on the illustration, it's still less than 0.5. Again, let's have our z-score table. Locate first the two digits of 0.69. The first two digits of 0.69 is 0.6. So the 0.6 in the first column, we have there. Next, we locate the last digit, which is the 0.09 in the first row. We already have that one. And then the intersection. The intersection is the value we are going to subtract to 1. The intersection value is 0.7549. So 1 minus 0.7549 is 0.2451. Thus, the area under z greater than 0.69 is 0.2451, which is less than zero point 0.5 because based on the drawing or our illustration, it should be less than zero point 0.5 because it's not, the shaded part is less than half of the curve. Now let's have the example in computing for area using the fourth condition. For the fourth condition, if z is greater than a negative value. So if z is greater than negative 1.43, we'll try to use again our standard curve. So we'll try to locate the 1.43, negative 1.43 in our curve. And we'll shade it to the right, so that's the shaded part. So that's the area that we're looking for. So based on the illustration, our answer should be greater than zero point 0.5 because it's more than half of the curve. So let's use the z-table to really get the exact value of the area. Again, locate the first two digits of 1.43, and that's 1.4 in the first column. And the next step is locate the last digit, which is 0.03 in the first row. And locate the intersection. And we have here the area is 0.9236, which is greater than zero point 0.5, right? So, based on our illustration, it should be greater than zero point 0.5. And we have here the answer is 0.9236. The area is greater than zero point 0.5. Moving on, we have here the fifth condition example. If z is in between two values. So find the area under z is greater than negative 1, but z is less than 1.32. So in our standard curve, we'll try to locate the two values. So we have there the two blue lines represents the negative 1 and the 1.32. And the area that we're looking for is the area between the two lines. So we have there. So first thing to do is to solve the value for z, the area for z less than 1.32. So 1.32, the first two digits is 1.3, and the second and the last digit is 0.02. So our answer is 0.9066 because this is under z less than 1.32 is under the first condition. So we just automatically get the answer based on the given values on the table. Then let's solve for z less than -1. This is under the second condition. So -1 on the first column, then on the row which is 0, then we have 0.8413. So we subtract 1 to 8413. So 1 minus 8413. So the answer is 0.1587. So we already have the two values of their areas. So we subtract the area or the answers for z less than 1.32 to the answer of z less than 1 point or less than -1. So we have a 0.9066 minus 0.1587. So the answer is 0.7479. So the area under z greater than -1 but less than 1.32 is 0.7479. And now let's have our activity 3, convert to z-score. So read the following situation and solve the required. So number 1. A sample of bags of potato chips in a factory has an average net weight of 23.5 grams with a standard deviation of 0.45 grams. What is the standard score for two samples F and G with the following weights? Our F is 26 grams and our G is 22 grams. So I'll give you time to solve for this. So while solving, let's have the second problem. The average score in statistics and probability tests is 12 and the standard deviation of 1.5. What is the standard score of the following students? A. Richard got a score of 16 and Angel got a score of 8. And now let's have the answers for our number 1 item or the first item. So based on the formula we have here, Z is equal to 26 since F is 26 grams. Then subtract it to the mean which is 23.5 and over 0.45 which is the standard deviation. It is just simple. We'll just use our calculator. So 26 minus 23.5, it's 2.5. So now we'll divide 2.5 to 0.45. And our answer is 5.56. So the Z score for 26 is 5.56. You get the answer? Very good. And now let's move on for our letter B, the G. So our G is 22, so we have there's 22 minus the mean 23.5 all over 0.45. And again, we'll just use our calculator. So 22 minus 23.5, we have here the negative 1.5 all over 0.45, and with our calculator, the answer is negative 3.33. You got it? Very good. And now let's have our second problem. For Richard, with a score of 16. So Z is equal to 16 minus 12 all over 1.5. So 16 minus 12, we have 4. Then divided by 1.5. And the answer is 2.67. Wow, very good. You got it. And now let's have the z-score for Angel. Angel got 8. So the z is equal to 8 minus 12 all over 1.5. So 8 minus 12 is -4. And -4 divided by 1.5 is -2.67. You got all correct? Very good. And now you're ready. Now let's move on to the next activity. And now let's have activity 4, solving areas. Determine the area under the region of the corresponding standard scores. So we have here 5 items. The first item, which is z greater than 2.31, z, and the second item, z less than 1.56, and number 3, z is less than 3.14. Fourth is z is greater than 0.83, and fifth, we have z is greater than 2 but less than 3.14. That's your time to solve for the areas. So while solving, I'll show you the answers and try to check later on if your answers are correct. For number 1, 0.10104 is the area. For number 2, it's 0.9406. For number 3, the area is 0.008. For number 4, the area is 0.7967. And for number 5, the answer is 0.0220. Again, you can go back after you are answering the area for this activity and try to check if your answer and my answer are the same. Probabilities. For any normal random variable, the random variable is transformed into a standard normal, and you can find probabilities using the standard normal table or the z-score table. The values written in the z-score table are all probabilities. In solving the 4 probabilities, it is the same in solving area under the region of corresponding standard scores, meaning we'll use the 5 conditions. Again, we'll use the 5 conditions. So we'll use the given z-score table. Solving probabilities and more. According to a certain study, height of the male student grade 11 students are approximately normally distributed, with a mean of 155 centimeters and standard deviation of 5.5 centimeters. Find the probability of a randomly selected male grade 11 student is shorter than 160 centimeters. First thing to do is to convert 160 to standard normal score or z-score. So we'll use the formula in getting the z. We have here 160 minus 155 all over 5.5, which is equal to 5 divided by 5.5, which is our z is 0.91. Since we are asked for the shorter than 160, so we are looking for the probability of z less than 0.91. Using our z-score table, the first two digits is 0.9 and the last digit is 0.01, so we have here 0.8186. Therefore, the probability of getting z less than 0.91 is 0.8186. Or we can say that there is 81.86% chance of selecting a grade 11 male student with a height shorter than 160 centimeters. Further, it suggests that when we try to select a grade 11 male student, there's a 81.86% chance that that student that we select is less than 160 centimeters. Another problem in solving probabilities and more. In one of the barangays in Mandawi City, there are 500 grade 4 girls. The weights of these grade 4 girls are known to be normally distributed with a mean of 30 kilograms and a standard deviation of 5 kilograms. Question: how many grade 4 girls in this barangay have weights less than 24 kilograms? First, we need to convert 24 to a standard normal score or z-score. So again, we'll use the formula. So we have here 24 minus 30 divided by 5. Or we have negative 6 over 5, or simply we have negative 1.2. Since we are looking for less than 24 kilograms, so we are looking for the probability of z, which is less than negative 1.2. With the use of our z-score table, the first two digit is 1.2 and the last digit is 0. So we have here 0.8849. Since our condition is under the second condition, So we subtract 1. So we subtract 1 with 0.8849. So 1 minus 8849, 0.8849 is equal to 0.1151. Then, we multiply the total number, which is 500, to the percentage, or the probability that we got. So 500 times 0.1151 is equal to 57.55. Thus, there are about 57 grade 4 girls with weights less than 24 kilograms. So we have two different problems. The first problem was getting the probability. Here is getting the number of grade 4 girls based on the population. Activity number 5, your turn to solve. In a job fair, 3,000 applicants applied for a job. Their ages were collected and said to be normally distributed with a mean of 28 years old and a standard deviation of 4 years. First question is, what is the probability selecting randomly an applicant with an age greater than 21 years old? And how many applicants are below 30 years old? It's time to solve. While you're continuing to solve, I'll reveal the answer, and after you answered or after you solve the problem, try to check whether we have the same answer. For letter A, the probability of getting or of randomly selecting an applicant which is greater than 21 years old is 95.99% or 0.9599. So there is a 95.99% probability of selecting randomly an applicant with an age greater than 21 years old in the said job fair. So out of 3,000, if you want to select one of them, there's a 95.99% chance that the one that you select is greater than 21 years old. How many applicants are below 30 years old? The answer is there are about 2,074 applicants with the age below 30 years old. So out of 3,000, there are about 2,074 that is below 30 years old. So the rest of the 3,000, which is the 926, they are 30 years old or above 30 years old. So if you have some suggestions, comments, and queries regarding our topic today, just give your thoughts under comment section or directly ask me through Messenger. Thank you very much and see you to the next topic. Bye-bye!